Welcome to this edition of Technician's Toolbox. This video will cover the specifics of the Ford electronic throttle control system. The accelerator pedal position sensor mounts to the top of the throttle pedal. There are 3 position sensors and 2 return springs inside. The position sensors send an analog DC signal to PCM. PCM uses APPS1 as the primary indicator of the driver's throttle demand. APPS1 produces a negative slope. In the idle position, voltage is high, usually starting around 4 volts. As the pedal is depressed, the voltage drops. With the pedal fully depressed, the voltage value will typically read just under 1.5 volts. APPS2 is used as a cross-check of APPS1. The positive slope provides a more traditional position sensor behavior when viewed on a scan tool. The voltage reading of APPS2 starts low in the idle position and increases as the pedal is depressed. In the event of a failure of the APPS1 signal, the PCM then uses APPS2 as the source of driver demand information. If APPS1 and 2 don't agree, APPS3 is used to cross-check APPS1 and APPS2. A malfunctioning APP will set numerous DTCs for circuit faults as well as performance or range faults. Please ask your parts supplier for information on a professional technician seminar clinic covering electronic throttle control systems. The electronic throttle body is very similar to the cable-operated throttle body with a few changes. Most noticeable change is the addition of the throttle actuator control motor. The motor is used to open and close the throttle plate based on direct command from the PCM. There are only 2 wires to the motor. The throttle position sensor has been redesigned for electronic throttle control. There are 2 sensors inside one housing, TPS1 and TPS2. TPS1 is used by the PCM as the primary source of throttle plate position under normal conditions. TPS is replaceable on some applications, but use caution. The bolts are soft and have blue Loctite on them. They snap off easy about halfway out. TPS1 operates in reverse to the traditional TPS in that it produces a negative slope. In the default position, the voltage is near the 5-volt reference voltage. As the throttle plate opens, the voltage from TPS1 drops. TPS2 is used as a cross-check of TPS1. It is also used by the PCM for small throttle angle changes because it has better resolution than TPS1. In the event that TPS1 fails, TPS2 becomes the PCM's primary source of throttle plate position. The voltage from TPS2 behaves in the traditional manner. In the default position, the voltage is less than 1 volt and increases toward reference voltage as the throttle plate opens. The voltage outputs of TPS1 and 2 also change at different rates. The rate of change of TPS2 is about twice that of TPS1. There are 4 wires going to the TPS, a 5-volt reference, 2 signal wires, and a sensor ground. The PCM has also received an upgrade with a new name, the Black Oak Power PC. This PCM is designed to run an ETC system and has extra computing speed and processors, some new diagnostic codes, and new strategies. Alright, let's do a case study. We've got a 2007 E150 with a 5.4-liter engine with almost 100,000 miles on it. Customer states, I was driving it last night, all of a sudden it lost power, lights came on, and it quit. Our quick scan shows numerous DTCs. Judging by the P2104, customers complain of an engine shutdown may have been exaggerated by either customer or the service advisor. The engine probably did not shut down, but was forced to idle, as the code description says. If it had been commanded to shut off completely, a DTC 2105 instead of a 2104 would have been present. Visual inspection of the APP sensors appeared normal, changing accordingly as the throttle was opened. However, APPS2 or APPS3 would break up and drop to 0 as the pigtail connector for the APPS sensor was wiggled. The female spade of the solid white wire, the signal for the APPS2, was suspected. The pin was removed from the connector. It looked slightly spread, but inspection was not conclusive. Ohmmeter testing from the end of the pin to the wire a few inches away was okay. Either the wire is losing contact with the APPS sensor's pin when wiggled, or the pin of the APPS sensor is losing contact inside the sensor. A new sensor was not in stock and had to be ordered, but a replacement pin with wire was available. The new wire and female pin were installed, but the problem remained. Replacement of the terminal did not fix the problem, so the accelerator pedal position sensor assembly was replaced and the problem went away. Thanks for watching Technician's Toolbox. See you next week.